I think desk fans haven't really changed in decades, so I decided to build my own. At first glance, it might look like a normal desk fan, but it isn't. It's been incredibly hot where I live lately, and since I spent most of my day designing new projects, I've basically been living at this desk. Naturally, I bought a fan. But after using them for a while, I realized they all annoyed me for exactly the same reason. They either blow air straight into your face, or they slowly sweep from left to right over and over again. And somehow I become more aware of the fan than the work I'm actually trying to do. The funny thing is, I never feel that way outside. A light breeze doesn't just blow in one direction, it constantly changes. Sometimes you barely notice it. Then a few seconds later, another small gust comes along from somewhere else before everything calms down again. That's when I started wondering, what if the problem wasn't the fan, but the way it moves air? And if that's true, could I build one that actually feels like real wind? At the time, I thought this would be a pretty simple project, but I couldn't have been more wrong. Once I had the idea, I spent quite a while thinking about how you could actually recreate natural wind. My first thought was surprisingly simple. Maybe I could just move the fan, but the more I thought about it, the more I realized that wasn't really the point. Natural wind doesn't just come from different directions, it constantly changes in strength, timing and position. That's when I started looking at something completely different. Modern car air vents. I really like how they let you direct the airflow exactly where you want it. And that gave me an idea. What if I could do the same thing but entirely in software? To make that work, I first needed the right fans. There are lots of different options out there, but I wanted this project to be affordable enough that almost anyone could build it. That's why I chose ordinary PWM PC fans. They're easy to find, surprisingly quiet, and only cost around $3 each. More importantly though, every single one can be controlled independently. At that point, it felt like the perfect choice. Looking back, it wasn't, but I hadn't discovered that problem yet. My first design was probably my favorite. Everything was hidden inside a monitor stand with the air traveling through a long internal channel before leaving through a row of slim vents at the front. I printed the first prototype, assembled everything, switched it on, and waited. The airflow wasn't terrible, but it also wasn't good. Something clearly wasn't working. For a while I blamed the fans, but after a bit of testing I realized something much more interesting. The fans were doing exactly what they were supposed to do, but my design wasn't. PC fans are incredibly good at moving large amounts of air. What they don't like is resistance. By squeezing all of that airflow through narrow ducts, I had accidentally created the exact situation these fans are worst at. So I stopped trying to fight physics and completely redesigned the project. Instead of forcing the air through complicated channels, I simply placed all 6 fans directly behind large front grills. The difference was immediately noticeable. Not only did the airflow improve dramatically, but the enclosure also became much easier to print. With the mechanical design finally working, it was time to bring everything to life. For the brain of the project, I chose this Waveshare ESP32S redevelopment board. It already comes with a 1.47-inch touchscreen, has plenty of GPIO pins for controlling all 6 fans, and is more than powerful enough for everything I wanted to build. Since the display is already integrated, it also keeps the electronics surprisingly compact, while giving me a clean interface to control the entire system. The rest of the electronics are actually fairly simple. Besides the 6 PWM fans, all I really needed was a power switch and a single 12-volt power supply. The only small challenge was that the fans need 12 volts, while the ESP32 only runs on 5 volts. Instead of designing my own power supply, I simply used one of these inexpensive DC-DC step-down converters. It takes the 12-volt input and converts it to a stable 5 volts for the controller. That means the whole project can run from a single power adapter without adding much complexity. And with that, the hardware was finally complete. But 6 fans spinning at the same speed wouldn't exactly be a reinvention of the desk fan. What really turns them into one system is the software controlling them. I didn't want to overcomplicate the interface, so everything can be controlled directly from this small display. The first mode is manual. Here, I can control the airflow myself using these 2 inputs and adjust the intensity in precise percentage steps. This gives me full control whenever I want a very specific amount or direction of airflow. But most of the time, I use one of the presets. Evening creates a very gentle airflow that slowly changes over time. Breeze is less predictable. It continuously varies the fan speeds to imitate the small gusts and pauses you would feel from a natural breeze. Wave moves the airflow across the desk in a repeating pattern instead of blowing continuously from one direction. Focus keeps the airflow more concentrated and consistent, which is the mode I mainly use while working. White activates all 6 fans together to create the broadest possible airflow across the entire desk. Turbo runs the entire system at maximum power for those moments when subtlety is no longer the priority. And finally, Silent keeps the fans at their lowest practical speed, providing just a small amount of airflow while remaining as quiet as possible. After using the finished fan on my desk for a few days, I'm honestly very happy with how it turned out. It doesn't just move a lot of air. I can decide where that air goes, how strong it feels, and whether it stays constant or changes naturally over time. And because everything is integrated into one compact enclosure, it feels much more like a finished product than 6 individual computer fans. There are already a few things I might improve in a future version, but for now, this has completely replaced the normal fan I was using before. If you'd like to build one yourself, you can find the 3D printing files, parts list and complete build guide on my Ko-fi. The link is in the description below. One small note before you start. I designed the enclosure around the exact fans I used for this project. If that particular model isn't available in your region, make sure any alternative fans have the same external dimensions and mounting hole positions before ordering them. Otherwise, they may not fit the printed enclosure. Thanks for watching, and I'll see you in the next project.